right, so now let's take a look at if the parent function, all right, f of x is equal to x squared. This is the parent function of a quadratic equation, all right? That is the parent function of a quadratic graph, all right? So a quadratic graph, remember briefly, forms a parabola. All right, it forms a parabola. Parabolas can be happy or sad, okay? And whether they're happy or sad depends on the leading coefficient, right? So if we have ax squared plus bx plus c equals 0, if a is positive, so if a is greater than 1, it'll be smiling. And if a is less than 1, it'll be a frown, okay? All right, just keep that in mind. Now, when we have the parent function of a quadratic, this right here is the child function, all right, of a quadratic. And it would also be a smiling or frowning. But if you look here, this is what changed from the first quadratic, the parent function, to the child function. So if I were to ask what change took place, you would say f of x, I'm sorry, not f of x, g of x. G of x translated 7 units down from f of x. Okay, it translated 7 units down from f of x. If we were to look at the type of graph that this would display, it would be a smiling face parabola, and I'm going to show it to you right now. All right, so if you take a look at the graph below, you'll see 2 parabolas. The very first one here, where it crosses the x-axis, or it crosses the origin, that is our parent function. F of x equals x squared. And if you look at the one below it, from the 0, 0, the origin, it travels 1, 2, 3, 4, 5, 6, 7 units down. So that means our child function is x squared minus 7. What if I were to travel from f of x equal x squared to g of x? Well, let me use h of x. H of x is equal to x squared plus 7. So that means I would start at my origin and go 1, 2, 3, 4, 5, 6, 7. And I would sketch my graph to go up in that direction. So that would be my h of x equals x squared plus 7. So that means it translated 7 units up.